DevOps on the .NET Core Engineering Services team with Matt Mitchell.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host. Make sure to check out www.azuredevops.show for past episodes and show notes. Upcoming in January will be another class, the .NET DevOps Bootcamp. So if you're looking for a hard-hitting, in-depth, immersive training class, then check that out. And now on to the show. Matt Mitchell is with me, and he is the lead engineer of the .NET Core Engineering Services team at Microsoft. And you can find a recent blog post of his at devblogs.microsoft.com/.net. And you want to search for a post called The Evolving Infrastructure of .NET Core. And Matt, welcome to the show. How are you, sir?
I'm good. Thank you for having me on.
Absolutely. Just for those who maybe haven't read the blog post or are not familiar with you, what's your journey been? How did you land in this position at Microsoft and on the .NET Core team?
Yeah. So I joined Microsoft in 2006 after 2 years as an intern in 2004 and 2005. And right out of the gate, pretty much for maybe 8 years or so, I did all C++ compiler work. Worked on Microsoft had a couple compiler projects. One called Phoenix, which you can sort of find some information about, and it's sort of sitting around in various places. And then I worked on a project called Midori for quite a while in research with Jared Parsons, actually, and former guest on your show. And and then that project got shut down, and we moved into the .NET Core team. My boss was working on the JIT compiler for C#, and I sort of had been doing all these years a bunch of infrastructure work. I worked when we work on the C++ compiler. I was responsible for our testing of the compiler using Windows builds, our sort of day-to-day check-in infrastructure. And so it's sort of I kind of morphed into doing the open source infrastructure for .NET Core.
Okay, that's awesome. And now this is a big job, engineering services. Can you dissect that for us? Differentiate it from, of course, maybe the .NET Framework engineering services team or the people who work on platform features. How is it all organized?
Yeah, so actually, I would say that what our job as a team is to provide a set of services and guidance and tooling that underpins the entire shipping infrastructure for the .NET Core product and ASP.NET Core. And those things are sort of, one and the same these days. The .NET Framework is a separate set of infrastructure managed by another team, and it has a lot of different sets or different requirements than the .NET Core infrastructure does. The primary reason being .NET Core is an open source product, and the framework is not. So the active investment that we're putting into like learning how to do to build and ship products in the open is going into the .NET Core side of things.
Okay, and so if I simplify it down to
Sure.
the DevOps pipeline for .NET Core, is that what you're responsible for?
For more than that. So if you talk about DevOps pipeline as the sort of the actual build infrastructure, that is a huge, a large space within itself. But this is everything from how do we test the product to how do we understand what we are shipping. And this is sort of an interesting space because like a lot of projects that exist in the open today, you are pulling in lots of different libraries, different components from different repositories, and you are deciding how you're putting those things together to ship and to build, and how do I keep them updated, that kind of thing like that. So there's this whole set of infrastructure around what we call dependency flow. And then of course, you have the build infrastructure itself. A lot of the stuff is actually what we aim for is we want to have the teams who are developing the code to be responsible for their DevOps pipelines, for the actual build logic. But the engineering service team is responsible for providing the right sets of tools so that they can easily work with the product as a whole, right? So we're talking about how do we put together sets of tooling to do signing and packaging and publishing to the endpoints that we need to publish to, such that the components that make up the overall product are sort of just plugging in and with minimal effort, and they can move really fast, and they can worry primarily about the quality of their code.
Okay. So how many different Git repositories overall make up .NET Core? How do you organize that and think about it?
So there's it really depends on what you count as like makeup. But I would say there's probably about 20 today that are, I would say that what we aim for is we have the latest version of that particular repository in the product when we ship a .NET Core preview or a .NET Core servicing release.
Okay.
And then there's a bunch of ancillary repositories that sort of, occasionally will get an update, occasionally which you might say are part of the product, but are not what we would consider in the traditional sort of old world of software development, like what did I build on every single build to ship out the door? You had like things that, tooling and other components that sort of, you just kind of checked into your repository and then you didn't really think about updating those things. But what did you build on every single time you built the product from source to ship it?
Well, I'm thinking about these teams that have multiple application teams. And for example, if they have a large system made up of, let's say, 20 different applications, each one in its own Git repository, but it's one system. So it's got a lot of coordination, and how other organizations using .NET need to put together their entire working environment when at the end of the day, you need one cohesive deliverable, but it's made up of many, many repositories, and thereby, from a human perspective, multiple teams. Even if there's not 20 teams, maybe there's 10 teams and each of them own 2 of the repositories. But either way, that's the same problem set, and it's all over the place. And I'm not talking about the small teams that have 1 or 2 apps. We're talking about companies that have a bigger set of software systems, and that's your world. I mean, the same context exists, but .NET Core has a lot going on. There's a lot of moving pieces.
Yes, absolutely. This is actually sort of an interesting space that I've been thinking about for a while, which is if we look back in the past, we had the monolithic repository was the way that we worked, and the monolithic repository works really well if you have, 1, the resources to go build your monolith at all times, and 2 is that generally if your team your organization is going to work really, really closely together, because there requires like a lot of coordination between teams to not step on each other's toes, right? And so as .NET Core moved into the open source world, what we sort of did, and we were kind of trailblazing in Microsoft at the time. There weren't really a lot of open source projects, and I don't know of anyone that was certainly the size of .NET Core, which was we then started to basically create a bunch of repositories for each sort of individual component. We say, okay, here's the libraries, here's the runtime, here is our installer setup, and then we say, okay, well then we've got the Roslyn compiler, then we've got the command line sort of SDK, and then all those pieces sort of like add up over time and say, okay, you know what? It's great. That means that the repository owner, the person who's responsible for that sort of feature area, works at their own pace. They define their own policies, and they produce their output artifacts in a certain way. And they kind of have a lot of control. And so this has a lot of benefits for that sort of individual repository owner. They can move pretty fast. And what ends up happening, though, over time is we then say, every 3 months, we're going to come together and ship a preview of .NET Core or a servicing release of .NET Core, and everybody needs to immediately work together. And when there's this sort of like fragmentation of our development environment, it makes that process of putting everything together a lot less efficient. And so I think that there's some evolving thinking on how you organize your repositories and organize your components such that you get the most flexibility from having things sort of split apart, but also are able to put things together in the end to ship a product. And this is this whole you get this with system design with microservices. It's like I could have a microservice and a set of certain microservices, and they all do their own little component really, really well. But what happens when I want to make a change that must affect all the other components? And so,
right.
So in .NET 5, we're actually going to take our number of repositories and reduce it by quite a bit. All the runtime repositories, Core Setup, Core, which is the installers, and then Core Effects, which is our libraries, and Core CLR, which is the runtime, have a bunch of sort of shared knowledge and shared components anyway. And so we're going to collapse that down into one repository and sort of try to reduce this sort of friction of how do we work in those different spaces, and then also how when we want to ship a release like that, you effectively every single time you've split out into another repository, you are introducing some level of build inefficiency into the system, in the sense that that is a unit that has to be built like on its own, and you need a new commit in order to to make a change in that space, and then you move to the next repository which has a dependency. It's another commit to pull in those new inputs and then do a build, and then and then there's with all the associated inefficiencies, getting machines, running your tests, producing a bunch of packages. And so we're going to try to reduce the number of repositories and sort of see where this takes us.
That's a really interesting spectrum that you just illustrated about choosing to go absolute or close to a monolithic system with single Git repository that it has low overhead from a build, verify, deploy, and not service, because it's all together. But the more and more expensive it gets to do that cycle, the more you may say, there's a better trade-off to split that up. And then on the other side, we had some guests on the show talking about microservices, where the absolute of that is a whole bunch, if there is an absolute, a whole bunch of Git repositories, but each one has its overhead just to maintain the whole build chain and the dependencies. And so it's an interesting decision of where on that spectrum to land and when you get the best trade-offs. But I'm wondering if there's different system types that would help the listeners grasp on, because I know that you shipped .NET Core 3.1 came out, right? So it's all this stuff got labeled with the same version and became a thing. But then a lot of people have systems where it's made up of, let's say, 20 Git repositories, but any individual one has a version number and could be deployed to production because there's only one production environment in the organization. And so it seems like there may be some different forces at play.
Yeah, I would say that there are some different forces. So if you're talking about so .NET Core, like when we talk about .NET, I would actually say that we have some similarities there. what we deploy as what we say like .NET Core is I would say what we deploy like a singular production thing, right?
Yeah.
Where those components generally are not shipping outside that vehicle. That's not the case for everything. We have cases like, for instance, the Roslyn compiler will ship in Visual Studio as well as in .NET Core. That does lead to sort of interesting things, like, for instance, this version in Visual Studio with should match the version that's in .NET Core if they're shipping in the same, or you could, or the same thing for VS for Mac or for VS Code, that kind of thing. Ultimately, I think the problems are somewhat similar between sort of the microservices worlds and this sort of like box product, if you will, kind of world, which is that there's the deployable unit is defined. The way we define it is if my deployable unit is the core, is what we would call like the core SDK repository, which defines the installers for the SDK. And if I were to walk that dependency graph below that, I could say that it says I pulled in a version of the command line parsers or the command line infrastructure, and then that then references a version of ASP.NET Core, which defines some things for the command line parsers or something like that. And then you can follow this all the way down to the bottom of the runtime part of the stack, and we can define that here's the set of things that need to go out to customers for a servicing release. And that's what I would say is like that's our deploy to production at that point.
Mm-hmm. Right.
Does that sort of answer your question, or are you thinking it a little bit different?
No, I'm absorbing all this because this is a huge system that you guys are developing and shipping out to the world with a tremendous number of customers, and so there's a lot of things that have to go right in order for it to work well.
Yeah.
But one thing I'm wondering is, so you have 20 repositories now. Regardless of the future, hey, we're going to collapse it down. Is there something that's going to be added that you're thinking, or an event where, hey, you know what, we might need to spin up a new Git repository. This new thing needs to be in a new Git repository. And what does your team provide guidance on how that needs to be set up if there's a 21st?
Absolutely, yeah. So this actually does happen a reasonable amount of time. There's plenty of good reasons to pull in new repositories. A good example might be we have the machine learning tools. ML.NET tools are in the .NET machine learning repository. And so what we think, what my team basically does is we define a set of shared tooling called Arcade, which defines in that blog post that's in the show notes, there's a bunch of discussion about this, which defines sort of a set of repository, I would say like a language almost. This is the way it should be laid out. This is the way that it should talk about its build commands. This is the way that it should produce its artifacts. It does some of this via templates in Azure DevOps pipelines. It does some of this via just plain old build scripts, and it does some of this via MS Build SDKs, which would define sort of typical sets of steps that should be run for most repositories. And so when somebody says, hey, I want to get a new repository, we would examine and say like, hey, what's the right place for this? Is it in its own repository, or is it if it's outside? And if it's outside, then we provide a set of shared infrastructure such that their onboarding process of like, how do we get my code building and running and shipping is fairly straightforward. And then they just basically integrate into this overall build process. Or maybe they ship on their own. Maybe they're just a repository shipping NuGet packages. But the whole point is that we sort of try to enforce quite a bit of consistency in how these repositories sort of build and are defined. Like, this is how you define your dependencies. This is how you identify where they came from, such that integrating into the larger product becomes a lot more seamless. And so that we can, if we need to make changes, we say, hey, you know what? Our signing infrastructure could use this kind of optimization. Applying those kinds of optimizations becomes fairly easy to do, fairly uniform across the stack.
Awesome.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
A few current announcements. The next date for the .NET DevOps Bootcamp, if you're looking for some intense training, another date has been announced for the course, and we've had a fantastic class in October. The next class will be January 16th and 17th in Austin, Texas, and the class is based on my latest book published through A Press called .NET DevOps for Azure. And if you'd like to learn more about how to set up a high throughput DevOps environment for your team, get your copy of the book, .NET DevOps for Azure, anywhere tech books are sold. Could you give us an overview of what that guidance looks like? I sense a lot of listeners at the edge of their seat saying, okay, there's a lot of .NET specific stuff that I probably don't care about. I don't sign my assemblies or anything for my organization because my own people use it. But if they do it this way, then maybe I should too. Can you give us maybe an overview on what things are not just Microsoft specific, but hey, we figured out that this is a really good way to do it?
Yeah, so I would say the number one thing that we do, and I'm pretty happy with, is that we use the standard .NET Core SDK, the Microsoft Net SDK, as part of our base build infrastructure. So we're not going to go off and define an entirely, custom build process. We are using the .NET Core in the same way that our customers are. And then beyond that, what I would say is that every organization has a set of common sorts of things that need to happen on build and test. And so what we do is we say, I'm looking across all of these repositories and all these build processes. What are those sort of sets of tasks that can be pulled out, and let's provide those as let's if we start from just the build side of things, a set of MS build tasks that are sort of plug and playable. Say hey, I need to do let's say it was signing is actually a pretty good one or maybe packaging. Packaging is a great one. So my organization packages in a certain way, and so I will provide some MS build tasks that everybody else will use, and those tasks have a specific contract that we try not to change over time, and they can then start using that stuff. And then on top of that, we would say, okay, what's the general form of these builds? And say it's build and then test and then publish. Maybe it's that set of steps. And we might provide a set of MS build targets, which would do a lot of that work. You say, okay, you know what? I'm going to start up a new repository. I define some sets of MS build properties that integrate with those MS build targets that my team has provided for me. And suddenly all the things start to light up. Maybe that means that at that point in time, you're not manually calling into all the MS build tasks that we have defined, but you're saying, okay, here are my source files, or here's the things in my, here's the projects in my solution that should be packed. And now suddenly all okay, as soon as it gets packed, that means that then it will get package signed automatically by our infrastructure. And so then we're sort of building up this base of functionality. And then what we do on top of that is we say, okay, well, I could have all of my teams go off and write their own Azure pipeline YAML files, right? And invariably what will happen is somebody's going to write it they're going to write it in their own way, and then somebody else is going to write it completely differently. Sure. And then if we're going to try, and then our ability to sort of come together as a product becomes more difficult. What you want is like, okay, if I'm working in repository A, I can like hop over to repository B, and I understand how it's put together, and that onboarding process for me, like to understand how to make my changes, especially to the infrastructure side of things, is needs to be pretty short. So then what we do is we provide a bunch of Azure DevOps templates that sort of integrate with build process. Say like, here's how we call our publishing tasks. Here are the stages we define for doing validation of our packages to make sure that they conform to Microsoft guidelines, things like that. Those are the standard steps that need to be run. And so all it ends up being is that their repository defines maybe their somewhat custom build commands that they have, but then pulls in the sort of standard templates for how we do the rest of the validation, or the rest of the build. So that's things like reporting what artifacts we actually did produce, as well as running our signing checking and things like that.
So architecturally, the MS build tasks are the way that individual teams are provided with the tools to call, so they don't have to duplicate that logic in their build scripts. And then for the YAML files, it's just guidance, template guidance, but that logic is duplicated in each repository?
No, so they're actually the Azure DevOps templates themselves as the native
that are
feature.
Stored in your Azure DevOps organization.
Yeah. So actually, what happens is there's a repository called .NET Arcade, which defines a set of common files that get synced automatically between all the repositories. So there's this. If you look at all the .NET Core repositories, you'll see an eng/common directory, and it has a bunch of base build scripts. It has things to do, like it has YAML templates. It has stuff to deal with, like cross building various operations, some bunch of stuff like that.
Okay, so you embed it.
Yeah, so what happens is when we produce a new build of Arcade, which is where this base tool set is defined, we get a bunch of new packages and a new Arcade SDK, which is an MS Build SDK. And that version will then flow to other repositories via an automated system. And those repositories will then get those new copy of the scripts if they happen to be updated.
In the form of a commit?
And so in a form of a commit, correct. Yeah.
Okay.
So the upside is that they don't have to worry about any of this stuff. And the other side of this is that if I want to go and make changes to that process, it's very easy for me to do. I mean, a classic one here is telemetry. So we talk about what do we do? Like, how do we like, let's say we want to inject some telemetry into the build to sort of identify how long steps are taking, or any number of things. What you can do is I then go edit those templates, and suddenly all that functionality begins to appear in those downstream repositories. And we have a lot more data and ability to sort of analyze where we should be making changes or improvements, that kind of thing.
Okay.
Yep.
Well, that's really interesting, and architecturally, that's kind of the same. I'm thinking that's the same thing that application developers do when they use NuGet. They search it. They are the ones searching for the NuGet package, but they pull it down, but they make a commit, and now that new DLL is in the Git repository. Whereas you guys say, okay, here's some source, and we're just going to put the source and do a commit. But either way, it's a dependency, and it's brought in, and now the dependency is owned by that leaf node Git repository.
Yes. So I would say there's actually two kind of cases. One is the source case. The reason that we put the source into the repositories for this specific case is, and this is for two reasons. One is because when we designed the system, it wasn't possible to pull the YAML templates from another repository. So today, what you could maybe do.
Oh, and now it is?
I believe, yes, you can pull them as a resource.
Okay.
At least I think that's possible. What you could do then, what you would say is, like, I would flow the version of the or the tag, like to say the git tag of the templates that exist in the other repository. So that's reason number one. Reason number two to pull in those build scripts by source is for bootstrapping. So when we would do is like, because we're a platform that produces .NET Core, we want to a lot of times build on SDKs, the new .NET Core SDK that maybe is not yet available natively within Azure DevOps. Like maybe it's the nightly build from last night type of thing. And so you need to be able to bootstrap that. And so what you need to be able to do is, okay, I went off and like we have a build.cmd, which then says, okay, go download the thing from our nightly drop and unzip it locally before you start to run. So that's sort of like that. That's why we put the scripts natively in the repositories. We also flow version numbers all over the place. So anything that is produced within a package. So any of our, for instance, our signing tasks are produced in package. That package gets published to a NuGet feed, and then we flow that version number via commit to any downstream repository. So in other words, what we tend to do is we do something very similar to what users typically do, which is I know there's an update to this NuGet package, and I'm going to go just find out what it is, whatever the fix is, what kind of interesting things are happening there. And then I'm going to update that version number in my repository. What happens as you get to fairly large numbers of repositories is that process does not scale to, so the classic example is like, I have a fix that is being made today, and I need to ship the build tomorrow. If that requires coordination between,
it's a pull.
It's a pull, and that just doesn't scale. Like there's no way that happens in a day.
Mm-hmm. You need to push it.
You need to push it. So what we say is we do pull it. In other words, but the process of creating that pull request is an automated system these days.
No, that makes a lot of sense, and I think that pattern can help people who have decomposed systems and have multiple repositories that just kind of need to have standards.
Yeah. Ultimately, what I think is that choosing the right number of repositories is the biggest way to sort of absolve some of this difficulty. And for every organization, there's going to be a right number of repositories and a right way to pull your code apart. And that number is going to change over time based on how your product is evolving, how it's shipping. Is it shipping in 10 different products and they all have different ship schedules versus, is it just a part of one larger product? And so the challenge is, how do you choose that number such that some of the need for crazy automated systems that can flow dependencies around and do all these automated pulls is maybe less critical?
Mm-hmm. No, you make a good point. Again, that spectrum is the fewer repositories that you can have and still keep your cycle time short is probably your balance point.
Yeah. I think honestly, I don't think I've come to a real understanding of the absolute right way yet, because I don't think there probably is one. But my first bit that I'm pretty certain about is that a lot of times we have taken repositories and used the repository boundary as a method of reducing build time. And we'd said, okay, because the repository boundary means that I'm going to have to produce some outputs, and then those outputs are going to be pulled into another repository. Effectively, what I've created for myself is like a caching mechanism. I'd said, well, like when I build repository, if we're flowing from A to B, if I produce packages in A and they reference them in B, I can rebuild B many, many times. I don't have to rebuild A because I've defined that I use version 1, right? in reality, that's probably not a spectacularly good way of doing a caching mechanism. It just forces you to do it. And so maybe it means that those repositories should be together, and then they should be building, live source all the time. If we have things like, I don't know if you're familiar with like a content-based build system, where you have a caching mechanism in the cloud. There's organizations that have these systems. They're not terribly easy to bootstrap into existing projects.
Well, give listeners a few examples of content-based systems.
Would be like Domino, or I guess Build XL in the .NET universe is a content-based build system. I think Bazel is in that's Google world. Google itself, I believe, has internally a content-based build system. And so if your users aren't totally familiar, the idea basically is you hash all of the inputs to a specific build command. Let's say it was compile this C# file, right? And you'd say, okay, well, the C# file that I'm compiling has this content hash, and all of the input DLLs have these content hashes. And if I the command line altogether, maybe with the environment involved too, has this content hash. And I'd say, hey, I would look up in a sort of a cache that say, has anybody done this before? And if they have done that before, then I can just pull down the output. This is very simplified because it gets to get it efficient is difficult. But if I can just pull down the output, then I don't have to do any of that work at all. And so if we think about that in terms of cross repositories, if I simply mashed two repositories together and I'm making changes in my let's say the B section of this repository,
Project B,
and in Project B, that I don't care about A, and I'm doing a build over and over and over again. I'm getting a perfect incremental build every single time, because I'm not, and effectively to me as a developer, it doesn't feel like I have a bunch of extra weight pulling the whole system down, and that cycle time for how we work efficiently in that one repository it sort of reduces quite a bit. And so I sort of think about, like, how do we pull our repository, define where our repository boundaries should live, is that defining them sort of based on what is the most efficient build infrastructure is probably the wrong thing, but how it kind of gets done a lot of the way today. And that maybe the right thing to do is to define it based on how, on product boundaries, how, like, where, say, like, if I have a product and it ships to many different customers on different cadences, maybe that makes sense to have as a separate component versus sort of just like a one-off repository that I've defined so that my build time could be low.
Yeah, that's a lot of great factors to think about.
Yes.
Before we close out, are there any, for people who want to dig in and learn more about content-based build systems or anything else that you mentioned, are there any go-to resources that you would point them to?
So the Build XL repository is probably a good place to start. The otherwise, I'm not actually sure, to be honest. We haven't looked to invest in moving .NET Core to a content-based build system yet. So for me, this is more when I worked on Midori. Midori had a content-based build system, which is actually is the precursor to Build XL. Okay.
And are those open source products or commercial products people can use on GitHub, I'm guessing?
Yeah, let me go find what the Build XL.
Okay. Yeah, we'll put those in the show notes. We'll get the URL. But man, a lot of great information. Absolutely fascinating show. I appreciate you being with me here today.
Yeah, I'm always down to talk about this stuff. Maybe in another 6 months, I'll have had enough thinking to really decide what the right repository layouts for like how those decisions should be made.
Well, you say .NET 5, you're going to rethink a few of those decisions, but heck, we'll definitely take you up on that. Get you back on the show.
Yeah, it would be really interesting to see what will happen. .NET 5 ships in November next year, and we're aiming to really have a lot of that sort of collapsing of repositories done by, I think, like February, March timeframe is really what we're aiming for, right when those first previews are starting to come out. And what I'm most interested to see is sort of like, how does it affect the developer productivity side of things, and also how does it affect our ability to ship a preview really rapidly. Right now, our build times are not great. Let's say we probably, the time to sort of put together a product is maybe around, I don't know, like 16 hours or something like that. Just because of all the official build and the pull requests at every single level. And so we're going to invest pretty heavily in this, and our aim is to get down to about 3, 4, somewhere in the range, while still maintaining all that flexibility. So we'll see what happens.
Awesome. Good stuff. All right. Well, thank you so much, Matt, for taking the time today. And for all you listeners out there fascinated by this topic, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.